Hello everyone, and thank you for taking time out of your day once again and for the first time to hear our presentation on tide rising. Now picture this. You walk outside like any other day, being greeted by the fresh air outside, ready to begin your day. Today is different though. You feel the capillaries within your lungs cringe and gasp for air. Your eyes water a little more, and you feel a slight burn. You look around the world and it looks different now. There's more water in the streets and more polluted air that is causing your lungs to feel like oxygen is being drained from them. You see the sewage running down the streets and downtown flooded. Before the Duwamish was channelized, it meandered through the floodplain and ran through South Park and Georgetown. Now that it's channelized, it has a smaller capacity to hold an increasing amount of water, threatening both communities. So the question is, why haven't we done something about the pollution and the sea level rising when there's still time? We are here once again to talk about the possible prototypes that can be implemented within each neighborhood. Each has been re-evaluated based on feedback we received from design professionals and how they would best adapt to different areas where major flooding occurs.
Before designing these prototypes, we looked at inventory and analysis of both Georgetown and South Park. Looking at sea level rise as a big issue today, if 12 to 15 feet, as predicted, were to rise in 100 years, you could see which areas of both cities would be flooded. Also looking at soil conditions, a big problem in both cities are liquefaction areas. And this could be a big problem if an earthquake were to occur near South Park or Georgetown. Also, you can see on the western part of South Park is a landfill, or actually landslide and seismic areas. And the southern part is a landfill. Southern part of South Park is a landfill as well. Looking at green space and tree canopies shows the layout of where these trees are located and parks in both cities, and where we could add more vegetation and more parks to accommodate their needs.
It was the end of September when the WSU Landscape Architecture Studio held 4 design workshops at the Georgetown Community College, where best practice designs were shared for climate change and sea level rise adaptation. At these workshops, both high school students and design experts were designed to participate in a design game where people could suggest specific locations where the proposed prototypes were shared during the workshop, or if any individual had any new idea for sea level rise adaptation. During the 4 workshops, there are multiple drawings that were collected from design professionals that were further compiled into a base map where all new ideas and suggestions were shared, as well as specific locations for the prototypes that were proposed, which included the street canals, floodable streets, increased vegetation, and floodable parks. The original floodable street that was proposed at the workshop consisted of a street that would rise in the event of a major flood, simultaneously with a hydroponic phytoremediation planter that would filter water that was going through the streets. And a concern that was brought up on the fourth workshop was what would happen if there was a fright or that would come through the street. Would this floodable street, would it be able to uphold its weight? And so we further looked into the Fright Master Plan of Seattle, the 2016 Fright Master Plan, and we looked at what are the major and minor traffic routes that are currently being held, and we implemented that into an evolved prototype that involved dual-purpose parking that also functioned as flood control. So in these major streets that fright traffic travels in. Underground, there would be garage parking. And in the event of a major flood, water could enter this garage and it would serve as a detention reservoir, and freight traffic could continue to be utilized in these streets. So this prototype led into elevated streets, which involved 3 different phasing situations. In the initial phase, the underground garage would be implemented in streets that have the major freight traffics, and we specifically looked at Marginal Way Street, which is parallel to the Duwamish River, and in phase 2, a super levee would be implemented, and the freight traffic would continue to go in the tunneled area, which would control air pollution, and the vegetated super levee, which would act as a first line of defense in an event of a flood. It would be used as a green belt, where both pedestrians and bicyclists can utilize this space. And ultimately, in phase 3, in the event of a major flood, where water would enter the underground parking and be used as a detention reservoir, as well as flooding the initial tunnel of the freight traffic, the green belt would be transformed into the elevated street for the major street traffics of the freight traffic. And this also would be a phase of opportunity to implement multi-purpose floating infrastructure. It could both residential and commercial that would tie the 2 neighborhoods together.
Now, Boardwalk. There was an interest in connecting the both neighborhoods as well. 8th Avenue was mentioned a couple of times for both connectivity and for a canal integration. Walking through both cities, you feel a sense of unity as if both cities are one. Having a floating pedestrian or bikeway that connects both of these neighborhoods really sparks this unity. People would be able to have more access to each neighborhood, reducing vehicular movement, and to be closer to the water. In this particular prototype, the boardwalk also helps clean the water through phytoremediation. Different pockets in the boardwalk also bring more green to the riverside. Trees are also included and placed through a technique called silvocell, where these cells are filled with uncompacted soil and allows roots to spread and receive nutrients and the water they need. The trees manage the rate, quality, and the volume of stormwater. When boats are trying to navigate through the boardwalk, also splits in the middle and at diagonal angle to the opposite ends of the river. Boeing was a big concern as well, from the contribution of pollution to being a major industrial player. Here, it was suggested, why not have a canal run through Boeing on the second workshop day? A canal was proposed to go under Boeing and the land strip. Seen here, we can see how far the canal would stretch and that they would hold a large amount of water as well. The prototype here was created by thinking of ways to create energy for access, for cleaning water and air, and sea level rise. For example, the landing strip would be risen up like a super levee to avoid flooding on the landing strip. The middle landing strip would be the highest and pyramid down cascading to each side. The 2 canals on the side carry contaminated water, one from high tide and the other one during low tide. The water is taken to the treatment plant under the phytoremediation greenhouses and released as clean water into the other canal chambers. The middle strip also has a canal that contributes to high flood storage. Each canal also has hydroelectric turbines that with water contribute to energy production. Going into more detail, in the middle of the landing strip, the canal chamber also served as underground parking and traffic movement for large industrial vehicles. There are 2 levels in the garage where ramps are used to move through them. Looking at the phytoremediation greenhouses, not just does water move through to be cleaned, but the polluted air from vehicles and tunnels and parking area as well. The air is filtered by plants and then released as cleaned air. The plants also are used for energy fuel for aircrafts if necessary.
Now we're going to look at the design called the Boeing Canal Walk. This proposed canal is located in Georgetown, just off Marginal Way. The before image shows railroad tracks and an undesirable pathway, and is also butted up to an industrial part of the town that separates people from the river. In the distance, you can see the Boeing buildings that stretch further south. This rendering shows how this space can be transformed into multiple uses. The canal diverts water from the Duwamish River and uses phytoremediation plants to clean the water. The railroad is to be elevated above the canal and add area for pedestrian pathways and bike lanes to create more efficient circulation. This section shows how this design may function. From the canal, water is pumped into the phytoremediation beds. The plants in these beds clean the water and eventually get pumped back into the canal and then back into the Duwamish River. The terrace planter beds allow for water to trickle down the concrete to create sound. This allows for a more naturalized experience for people in this space. People in both Georgetown have complained about how there should be more improved access to the river. This may be a possible alternative by bringing the water closer to them in a green urban space. The next suggestion that was decided by the design experts was the addition of a water treatment plant in South Park. Here shows a, or let's see here. The next suggestion was this water treatment plant that was proposed in the location of western part of South Park. And the before image shows the site. What you don't see in this image is underneath and underground. The landfill is shown, that is shown on the soils condition map, is presented underneath this whole site. Here's the proposed water treatment plant that obtains multiple uses. The top of this building is a park design that incorporates a pathway system through the whole area. The bottom portion of the building is a mass phytoremediation planting to filter contaminants in water, and also these test plots that are on top of this treatment plant as well, to test different toxins in different plants to see which plants can take out toxins. The upper portion of the park consists of a more traditional park layout. This area contains space for recreational activity and an amphitheater for events, also additional green space. Now we look at the section of this site. We can see how this water treatment plant actually functions. The subsurface shows the landfill underneath the water storage to allow for the building to float. One use is burning the mass phytoremediation plants. We can create green concrete that can be used for sustainable design on this site. From the landfill, we can collect methane gas that can be burned to generate heat and eventually electricity. Biomass from the landfill can be used to create biofuels through a process known as hydrothermal liquefaction. This process converts waste by elevating temperatures and pressures to create a very valuable and expensive diesel fuel. And lastly, heat exchange is needed to create power and to keep the site running and functional. The idea of this treatment plant is to collect water from other prototypes such as Ola's floodable streets. Simply, water can equal money, and every drop collected is important. So again, thank you for your time, and I hope you enjoyed our presentation.